Good evening, ma'am. We have finally incorporated the thresholding into the system, and also we were able to transmit the OFDM's signals and do thresholding on that too. We'll show two demonstration videos. In this first one, we'll demonstrate the different aspects of the thresholding that we have done. So first, uh, looking at the front panel, there are a few things to understand. This is the main LED that shows the presence or absence of a carrier or a user. Then this is a switch. In its off condition, it will search at the sender frequency for the presence of a user or the presence of a prominent energy signal. So if that is off, by default it will search above the sender frequency for a fixed number of carriers. You do the periodogram method for thresholding, wherein you add the magnitude of the power levels and do a thresholding on the sum. And we don't sum throughout the entire spectrum, but just for a fixed number of frequency indexes about the sender frequency. Now, for this, if the switch is on, if the switch is on, it will search for any given any frequency that we give at this point. So with the sender frequency as 90 megahertz, and if we change the frequency to search for to say 90.5 megahertz, it will change the sender frequency to 90.5 megahertz and search about that point. The sender frequency remains at 90 megahertz, but the search, the thresholding criteria, the frequency for thresholding shifts to 90.5 megahertz. So while doing the search for the sender frequency, if we transmit at 90.5 megahertz, we won't get a thresholding. That means that the signal is not present at the sender frequency of 90 megahertz. It will become more clear once we demonstrate it. So now the switch is off, so it is basically a sender search. So Ashish will transmit a signal at 90 megahertz through the same Nokia phone. So as you can see, as the phone is close to the receiver, the light is blinking. Now as he moves the phone away, as the strength of the spectrum decreases, the detection is gone, sensing is gone. Now if he moves it again closer, it senses the spectrum. So it goes again. So basically, for transmitting, we have used the antenna from a old radio, and for receiving, we have used a simple wire as earlier. Now, this is the basic case. Now, if we switch on, as described earlier, for off for sender search, we switch it on. Now, what happens is it will search for any given frequency that we give. So here we give the system to search for a frequency at 90.5 megahertz, and the sender frequency is 90 megahertz. So this is the spectrum. Now if you transmit it again at 90 megahertz, since the system searches for the frequency about 90.5 megahertz, it shouldn't threshold. Let's see. So as he moves the phone near to the receiver, we don't see the LED blinking. That means sensing is not done, or about 90.5 megahertz there is no carrier, and the carrier is present only at 90 megahertz. Now let's change the frequency to 90.5 megahertz. So once we move it to 90.5 megahertz, we see the signal being sensed. Once we move it away, it goes, and once we brings it closer, it again blinks. This is what is happening here, and that's the SDR kit. So this is basically the spectrum sensing with the thresholding that we have done, and all other parameters are set here in the front panel. The LabVIEW file as such is this, and it's a pretty long one. So this is basically the thresholding aspect that we have done. Now we have incorporated this into the OFDM system as such. The OFDM system, now we transmit the OFDM signal and sense the presence of the OFDM signal as such, and do the similar kind of thresholding. That's part of the second video. Thank you, ma'am.